In the annals of scientific exploration, few claims are as audacious as the recent assertion by engineer Dr. Evelyn Wright. Dr. Wright has boldly announced the discovery of rocket fuel-free space travel, a concept that has long been the stuff of science fiction. Dr. Wright, a rising star in the aerospace community, has stunned the world with her revolutionary proposal. Her work has garnered attention not just for its ambition, but for the meticulous research and innovative thinking behind it. Her groundbreaking research, if proven true, could redefine the boundaries of human ingenuity and usher in a new era of space exploration. This could mean a future where space travel is more accessible, efficient, and sustainable. Dr. Wright's claim, unveiled at a packed international conference, has sent shockwaves through the scientific community. The room was filled with a mix of skepticism and excitement as she laid out her vision. Her presentation, filled with complex equations and intricate diagrams, outlined a theoretical framework for a propulsion system that defies conventional wisdom. The equations suggested a new way to harness energy, one that could potentially eliminate the need for traditional rocket fuel. The system, she argues, can propel spacecraft to unprecedented speeds without the need for traditional rocket fuel. This propulsion method could drastically reduce the cost and environmental impact of space travel. Her colleagues, initially skeptical, were captivated by the elegance of her equations and the sheer audacity of her proposal. The room buzzed with discussions and debates as scientists and engineers began to grasp the potential implications of her work. The implications of her research are nothing short of staggering, promising to revolutionize space travel as we know it. If her theories hold up under scrutiny, we could see a new generation of spacecraft that operate more efficiently and travel farther than ever before. If Dr. Wright's claims hold true, humanity may be on the cusp of a new age of cosmic exploration, one where the limitations of rocket fuel no longer bind us. This breakthrough could open up the solar system and beyond to human exploration, making interplanetary travel a reality within our lifetimes. The scientific community is now eagerly awaiting further validation of Dr. Wright's theories. Teams around the world are beginning to test her equations and build prototypes based on her designs. The excitement is palpable as the possibility of a new era in space travel seems within reach. As we stand on the brink of this potential breakthrough, the world watches with bated breath. The success of Dr. Wright's research could mark a turning point in human history, one that propels us into a future where the stars are within our grasp. Imagine a world where space colonies are not just a dream, but a reality, where humans live and work on other planets and space travel is as routine as air travel is today. This is the vision that Dr. Wright's research promises, a vision that could transform our understanding of the universe and our place within it. Dr. Evelyn Wright's daring claim has set the stage for what could be the most significant advancement in space travel since the moon landing. Her work is a testament to the power of human ingenuity and the relentless pursuit of knowledge. As we look to the future, her vision inspires us to dream bigger and reach further than ever before. For centuries, humanity has gazed at the stars, yearning to break free from the gravitational shackles of Earth. The night sky, with its twinkling stars and mysterious planets, has always been a source of wonder and inspiration. Ancient civilizations meticulously charted the movements of celestial bodies, dreaming of the day when we could traverse the heavens. Our journey into space, however, has been fraught with challenges, largely due to our reliance on rocket fuel. The dream of space exploration became a reality in the 20th century, but it came with its own set of hurdles. The development of rocket technology was a monumental achievement, yet it also highlighted the limitations imposed by our dependence on chemical propulsion. The immense energy required to escape Earth's gravitational pull necessitates massive rockets carrying tons of highly combustible fuel. These colossal machines towering over the landscape are engineering marvels. The roar of their engines as they ignite is a testament to human ingenuity and determination. However, the sheer scale of these rockets underscores the challenges we face in overcoming gravity. This reliance on rocket fuel has several drawbacks, limiting our ability to explore the cosmos fully. Once in space, the constraints of fuel become even more apparent. The vastness of the universe beckons, but our current technology restricts us to relatively short missions and limited destinations. Firstly, the sheer weight of the fuel significantly reduces the payload capacity of spacecraft. The more fuel a rocket carries, the less room there is for scientific instruments, supplies, and crew members. This trade-off between fuel and payload is a constant challenge for mission planners. This limitation restricts the amount of scientific equipment, supplies, and crucially, human passengers that can be transported. Every gram of weight must be carefully calculated and justified, often leading to difficult decisions about what can be included in a mission. Secondly, the finite nature of rocket fuel imposes severe constraints on mission duration and distance. Spacecraft must adhere to strict fuel budgets, which dictate their trajectories and limit their ability to make course corrections or explore new targets of opportunity. Spacecraft are often forced to follow predetermined trajectories, limiting their flexibility to explore celestial objects of interest. This rigidity can prevent missions from taking advantage of unexpected discoveries or changing conditions in space. Furthermore, the production and transportation of rocket fuel pose significant environmental hazards. The process of manufacturing rocket fuel involves toxic chemicals that can have devastating effects on the environment if not handled properly. The toxic chemicals involved in its manufacturing and the potential for catastrophic accidents during launch highlight the inherent risks associated with this technology. Accidents can lead to chemical spills, fires, and explosions, causing long-term damage to ecosystems and human health. Dr. Wright's proposed alternative, therefore, offers a tantalizing solution to these challenges, promising a future where space travel is safer, more sustainable, and infinitely more ambitious. By exploring new propulsion methods and innovative technologies, we can envision a future where the tyranny of gravity is no longer a barrier to our exploration of the cosmos. This new era of space travel holds the potential to unlock the mysteries of the universe and expand the horizons of human knowledge and achievement. At the heart of Dr. Wright's revolutionary concept lies a technology she calls the quantum resonance drive, QRD. This enigmatic system, she explains, exploits the bizarre yet fundamental principles of quantum mechanics to generate thrust. Unlike conventional engines that rely on the expulsion of mass to propel a spacecraft forward, the QRD manipulates the fabric of space-time itself. While the specifics of the QRD remain shrouded in technical jargon, Dr. Wright has offered a simplified analogy to explain its workings. Imagine, she suggests, a surfboard riding a wave. The surfboard in this case represents the spacecraft, while the wave symbolizes the fabric of space-time. Just as a surfer can navigate the ocean by harnessing the energy of waves, the QRD propels the spacecraft by creating ripples in spacetime. These ripples, generated by manipulating the quantum fluctuations of the vacuum, create a gradient in the fabric of spacetime, effectively pulling the spacecraft forward. This ingenious mechanism, if realized, would allow for constant acceleration without the need for any propellant, essentially freeing spacecraft from the constraints of traditional propulsion systems. The potential applications of Dr. Wright's quantum resonance drive, or QRD, are vast and awe-inspiring. This groundbreaking technology could revolutionize space travel as we know it. With the ability to accelerate continuously without the need for traditional fuel, spacecraft equipped with this technology could reach unprecedented speeds. This would drastically reduce travel times within our solar system and beyond, making what once seemed like distant dreams a tangible reality. For instance, missions to Mars, which currently take 6 to 8 months, could be accomplished in a matter of weeks. This would not only make manned missions more feasible, but also open the door to more frequent and extensive exploration of the red planet. Moreover, the QRD's ability to manipulate spacetime could unlock entirely new avenues for exploration. Imagine a future where the boundaries of our solar system are no longer a limiting factor. By warping the fabric of spacetime around a spacecraft, Dr. Wright suggests that it may be possible to create wormholes, theoretical shortcuts through the cosmos. This concept, once confined to the pages of science fiction novels, could become a reality, allowing us to traverse vast distances in the blink of an eye. Such a feat, once relegated to the realm of science fiction, could potentially allow for interstellar travel, opening up the universe to human exploration. We could visit star systems that were previously thought to be out of reach, expanding our horizons like never before. The implications for scientific discovery are profound. The QRD could enable us to send probes and telescopes to distant star systems, providing us with a closer look at the universe's most enigmatic phenomena. The ability to deploy probes and telescopes to distant star systems could revolutionize our understanding of the universe. We could gather data from regions of space that were previously inaccessible, leading to groundbreaking discoveries. We could study exoplanets in unprecedented detail, search for signs of extraterrestrial life, and unravel the mysteries of dark matter and dark energy. The QRD could provide us with the tools we need to answer some of the most fundamental questions about our existence and the nature of the universe. The QRD, if successful, could usher in a golden age of astronomical discovery. It could transform our understanding of the cosmos and our place within it, opening up new frontiers for exploration and scientific inquiry. The future of space exploration is bright, and the QRD could be the key to unlocking its full potential.